Hi all. Today let us discuss about the characteristics of junction field effect transistor. So there are two important characteristics of a junction field effect transistor. One is drain characteristics and another one is transfer characteristics. So first we will see the JFET characteristics, drain characteristics. So this graphical representation shows that drain characteristics of a n-channel JFET, that is in the x-axis it is VDS, drain to source voltage, and the y-axis it is marked as drain current in terms of milliamps. And you have plotted that for various values of gate to source voltage, we have drawn the plot, that is ID versus VDS. For example, first we have drawn for VGS is equal to minus 3 volt, then VGS is equal to minus 2 volt, then VGS is equal to minus 1 volt, such a way VGS is equal to 0 volt. So in the graphical representation, it is marked that ohmic region, that is the curve, that is 0 to A, that is O to A, it is marked as ohmic region. Then the curve A to B shows that saturation region. Then the point B that shows that breakdown region. So generally first let us discuss about what this relationship between in this curve. So this curve will represents the relationship between the drain current and drain source voltage, that is VDS, for different values of gate source voltage. So first let us discuss about the ohmic region. So this ohmic region, or it is called as linear region. So in the graphical representation we have seen that the point from O to A, that region we have marked it as ohmic region or linear region. So in this region the drain current ID increases linearly with the increase in drain source voltage. So when JFET is operated in this region, it will act as a simple resistor. Okay. Then followed by this ohmic region, the second part is pinch-off voltage, that is represented by VP. So the point A in the curve is called as pinch-off point. So as we increase the drain source voltage, the depletion region towards the drain increases, but at some point it will merges. Okay. So the point where the depletion region merges is called as pinch off, and the voltage which causes the depletion region to merge is called the pinch off voltage. So once the pinch off voltage, that pinch off occur, the drain current will becomes constant. Okay. So already we have discussed ohmic or linear region. The next pinch off voltage. The third one is the saturation region. So this saturation region in the graphical representation, it is the curve A to B. So in the saturation region, the drain current ID will remains constant irrespective. That means whenever you are keep on increasing the VDS voltage, the drain current will remain the constant. So when the JFET is operated in this region, it acts as constant current source. So that particular region is called as saturation region. Then followed by this breakdown region is there. The breakdown region, suppose if drain to source voltage is increased beyond some limit, okay, then what happened for the drain current? The drain current will increases rapidly, so that the entire device will get damaged. So that particular region is called as breakdown region. Okay. Then this is the transfer characteristics of JFET. Here in this curve, it is where we can see that the bottom end of the curve on the VGS axis will represent this as VGS off, when VGS is equal to 0, the pinch off voltage will be minus Vp. Therefore, the drain current will be 0. And this top end, we can see that the ID axis will represent the maximum drain current, and that is represented by IDSS. That is represented by IDSS. That means when VGS is equal to VGS off, we will call that 0 drain current. When VGS is equal to 0, the drain current ID is equal to in maximum level. That is shown by the top end of this curve. So then followed by this, the square law expression for drain current. Okay. So this relationship between ID and VGS is defined by the Shockley's equation. Therefore, the formula is defined as drain current ID is equal to IDSS into 1 minus VGS divided by VGS of the whole square. Here the pinch off voltage Vp is equal to VGS off. Okay. So in order to obtain the transfer characteristics curve, we can use this two condition, that is when VGS is equal to 0 volt, ID is maximum. When VGS is equal to Vp, that is pinch off voltage, the drain current ID is equal to 0 milliamps. So this is the way this will combine from how the transfer characteristics has been sketched from the drain characteristics. So the drain characteristics, ohmic region, saturation region, pinch off region, breakdown region is the, from using that we are drawing the transfer characteristics. When VGS is equal to 0, ID is equal to IDSS, and VGS is equal to Vp, we are obtaining the drain current as 0. The next, followed by the transfer characteristics, let us discuss about input resistance. So this input resistance is nothing but the JFET will operate in reverse bias condition, so that the input resistance at the gate will be very high. So one of the advantage of the JFET over the BJT is high input resistance. Therefore, we can write the formula in mathematical way, that is an expression, input impedance or in is equal to modulus of VGS divided by IGSS. Okay. These all are about the JFET characteristics as well as the input resistance. Thank you.